Okay, so for the predefined functions in C++, we're going to be looking at ones that are standard functions that are included with C++. Typically, when you install your compiler, these libraries are available to you. We're not going to look at the standard template libraries I mentioned or third-party libraries like Boost right now, but we will look at just some of the ones that are available. And we've already seen one example of a library, which is IOStream. And IOStream is what we use to do things like cout I, right? That uses IOStream. And we can tell that it's using that library because if we actually go now and we compile this and run it, it works, right? But if we actually took out the library here, the include statement, what would happen? It gives us an error. First off, it tells us, it gives us a warning about the STD, but then it says there's an error. Cout, the use of an undeclared identifier cout. So it doesn't know what cout is. So it can't use output streams if we don't include the library. Yes?
Could you define a function in
You could actually define your own output stream if you wanted to. Here's the thing though. There's already a good one that's provided. So the thing is why would you, right? So some of these things here, the stuff that's in predefined are usually really standard things that everybody uses, that it's much easier to use the version that already comes with it than to create your own. If you needed to, though, in some cases it is appropriate to create your own libraries in special circumstances where you want to create a special version or an optimized version of the library that's provided, or when you want to provide functionality that isn't included in one of the libraries that C++ gives you. Yeah. I'm not going to be covering anything about that, but you can do that. There are different ways you can do that. So, for example, that you can actually sort of extend the functionality of predefined functions. And probably you'll talk about that more in next semester than this semester. But some of the techniques that I'll show you later, you could use for that purpose. So maybe I'll mention it later in the course, but not right now. So one of the libraries I do want to show you is everybody loves math, right? That's not enthusiasm. Do you love math? Okay, so there was a couple yeahs in case the mic didn't pick that up. So what I'm going to include is I'm going to include a library called CMath. And I'm going to show you an example here. So we're going to do an example with the CMath library. What do you think would be in a library called math? What? Pi. Yeah, basically mathematical functions, right? Things that you typically would do on your calculator, that aren't already provided by basic operators like plus, minus, division, and so on would be here. For example, how many of you know what a square root is? Everybody, okay. Can you do them in your head? Some, but not all. So it turns out one of the things that you can actually do here is you can actually do square roots. So I'm only printing this out so you see it, but what I'm going to do here is I can use square root 5.0. Does anyone know what the square root of that is? Well, we know it compiles. It's 2.23607. Now, I didn't know that off the top of my head. But if you wanted to do a square root, you could create your own function called square root and calculate this. But the thing is, why would you when there is a one that works provided? So using the math library, by including CMath, we now have the ability to do things like square roots if we want. What's another one that you could do? What about, you ever seen power? Like when you do like something like 2 to the power of 3, that kind of thing, right? So what if we can also do something called PAL. Now, in this case here, does this mean 2 to the power of 3 or 3 to the power of 2? Are you sure? You're just guessing, right? So this is a good thing where if I was you in the class, one thing that you might want to do is you might want to look up the CMath library as we're talking, and then you can actually see information about what other functions are available in that. I'll include a link to some documentation on this on the course website. But the other thing is, if you weren't sure about these things, in addition to documentation, actually running them can actually help tell you. So if this is 2 to the power of 3, what should the answer be? 8. And if this is 3 to the power of 2, what should the answer be? Okay. So let's actually compile this one and run it. And what do we get? 8. So we could go through and do a whole bunch of math operations right now, and I could really impress you with how many different things are in this library. I don't want to do that because what I think is, I think it's more important that you know how to use a predefined library, which I've shown you, and that it exists. So if you need to do some sort of math operation, I've shown you now where you can actually go. So there's also other libraries as well. Have you guys ever wanted to do random? So if I wanted to print out a random number, say, less than 40. And actually, I'm just going to print this out this way. I'm not going to have any message. If I wanted to print out a random number less than 40, what would I do? I could do something like this, right? This generates a random number, mod 40. Why would I mod 40 here? What does mod do? Gives you a remainder. So if you took any number and modded it by 40, what are the remainder values? What can they be? 0, 1, 2, 3, up to 39, right? So if you take a random number and mod it by 40, it will give you the remainder, which will be some range of 0 to 39. Yeah? You're jumping ahead of me a little bit. That's okay. No worries at all. So if we actually compile this now, will this work? So what is... Oh, I didn't actually save the program. That's usually helpful. It says 7. Cool. What if I run it again? 7, 7. And what about if I did this? If I printed out 4 of these and did this? 7, 9, 33. Now, what you could do is instead is you can seed. So a random number, here's the thing about the random number generators in most programming libraries. They're not random. They're a random sequence of numbers that always start at the same, they have a similar starting point. So if you run it again and ask it again, it'll always give you the same result, right? So there's something called seeding where you can go, seed the random number. So let's say 42, because that's always a great number. So this seeds, this sets the seed for random numbers. Now, if we run this now, the other thing is, otherwise, if we don't seed, then rand will return the same value. And this generates random numbers between 0 and 0 to 39. So if we now compile this, what we notice is right away, hey, when we use a seed, it generated a different set of random numbers for us. Oops, I didn't need to compile it again. But wait a second. It generates the same one. So if we change this to 50, and we now compile and run it, it generates a different, so 50 with this as a seed generates a different one than 42. But if we run it again with the same seed, what's happening now? basically the seed gives us a different set of numbers, but if you use the same seed again and again, it gives you the same random numbers. So how do you get a different seed every time? There are a couple of ways you can do it. One of the ways is, for example, you could just ask for a seed from the user, but that's not really practical. Another thing is you can actually set the seed based on something like, for example, the clock, right? So the time. So you can get the time and use that as your seed. So we're going to do that. I'm going to pause for just a second, and I want you guys to do something. I want you to look up how to actually, what library would allow you to get the clock time. Okay, so we're now back. Just one comment that I'll mention for those of you listening on or watching this. A couple students mentioned that using the RAND and SRAND didn't compile, and that was because you also need to include the cstdlib as well. I forgot to type that in, but it did compile on mine, and that has to do with platform differences in terms of what gets included automatically in terms of libraries when you do compilation. Was there a question over here?
Yeah, so when we're referencing time library, why can't we use time library when we're including the library? It said C time, but you can also use time library.
There are different ways of doing it, and there are different versions of libraries. So what library did most people find, though? What? Time.hc time. So we'll include, what was C time? Was C underscore time? C time like this? Okay, and what we're going to do is we basically want to replace this 50 with the time. So what's the function we're going to use in here? Time is actually a function which returns the current clock time. And if you want to see what it looks like, we can actually display out time. This can actually take as a parameter a timer, I think it is. But you can also use null here, and it just basically will return the current time. But if there was a parameter value set here, it would actually set that timer to be the current time. So I'm just going to display out the time. I'll put that in quotes. And actually, I'm just going to get rid of these things because we don't need to see them right now. So what I'm going to do here is I'm going to just call that time here. Now, of course, this time is going to be slightly different this time because it's calling the function twice, but you get the idea here. What? It'll be pretty close, but I just want to point out to you that, in fact, what time does, it's more just for you to see what the format of this is. So what we're going to do now is we're going to use the current time as our random seed, and then we're going to generate a random number from that, which is between 0 and 39. So let's actually just clear our screen here. I'll save this, and now let's compile it. Oh, we got an error. C time. Yeah, usually you have to spell things correctly for it to work. Thank you for mentioning that. And it actually told me if I'd actually looked at my message, it tells you right where the error is. So that's good to know. And if we run it now, it says the current time, wait a sec, this isn't a very good representation of time. That's okay though, but it starts off with 18, 8, 7, and 12. If we run it again, we get a different number, and we get a different sequence. Different sequence. And you can see that the sequence keeps changing. Why? Because we keep using a different time. Now, this time here is, does anyone know what time is? What does it return? Yeah? Unix time? Is that what it said when you looked it up? Or are you guessing? Oh, okay. Can anyone confirm that? What did it say it returns in the library? It returns time as what type of object? Yeah? So yeah, and that can get converted to an integer as well, which is what we're going to pass in here to SRAND. So if you wanted, yeah?
The library sends a
Yeah, so you're looking at here, this is the number of seconds. So you can also represent it, if you use a time object, you can also get it, and it will, the thing is, it can convert that number of seconds into a specific day and everything else. So that is something to, I just want to mention that. So the time here, the key thing here isn't how it's represented for you guys, it's the fact that every time you run it, I shouldn't say time, every instance that it's run, when that time function gets called, it actually returns a different value, which means you use a different seed, which means you get a different set of random numbers.